Okay, now that we're familiar with equations of lines, we've reviewed that, let's talk about parallel and perpendicular lines in particular. So, parallel lines, what are those? Those are two lines in a plane that never intersect. We're still in two dimensions here. So, for example, if I asked you to graph y equals 7, what does that look like? Well, remember, y equals, that means it doesn't matter what x is, the y value is always 7. So it'll look like that. And then what about y equal 2? No. There we go. Y equal 2. Let's get that one out of the way. So there's y equal 2. So those two lines, they're both horizontal, they're parallel. They'll never intersect no matter how far you go to the right or to the left. What if I asked you to graph x equal -3 and x equal 8? So remember, an x equals a constant. That means that all the x coordinates are -3. The y coordinate can be anything. So when x is -3, you'll have a vertical line there. And when x equals 8, you'll have a vertical line there. And those are obviously parallel as well. They will never intersect no matter how far up or how far down you go. So horizontal lines are parallel and vertical lines are parallel. What if our lines are not horizontal or vertical? What if we had y equal 1/2 x plus 1 and y equal 1/2 x minus 5? What form are those in? Well, hopefully you remember that's slope-intercept form. So first let's take a look at the graph. If I wanted to graph y equal 1/2 x plus 1, I guess I would use the y-intercept. Let's make an arrow here so I can show where I'm looking at. So I know the y-intercept is 1 for the green line. That means it goes through y equal 1. And I know the slope is 1/2. That means from that point, if I go up 1 and over 2, I'll be on my line again. And I could keep doing that, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, etc. And that's the line I would get. How about the next one? How about y equal 1/2 x minus 5? The y-intercept is -5. So let's put a point there, -1, 2, 3, 4, -5 on the y-axis. The slope here is also 1/2. So that means I'm going to go up 1 over 2, up 1 over 2, and I'll keep putting these points on my graph, and then I'll connect them. And I get that. And if we are really accurate when we draw this, we're careful, you can see, yeah, those are always going to be parallel. They'll never intersect. And what's our intuition tell us? Well, because they have the same slopes, from any point to another point, we're always going up 1 over 2. So because they have the same slant or the same slope, we know they're parallel. So if two different lines have the same slope, then they are parallel. So we didn't even need to graph them. We could have just looked at the two equations, and if we knew enough about slope-intercept form, we'd say, hey, they both have a slope of 1/2. We're done. All right, what about perpendicular lines? Well, perpendicular lines are two lines that not only do they intersect, but they intersect specifically making a right angle or a 90-degree angle. The x and y axis, for example, those are perpendicular. So our Cartesian coordinate system is based on this perpendicular lines. What if I ask you to graph y equal 4 and x equal -6? So let's graph that. Y equal 4, that's going to be 1, 2, 3, 4, that's a horizontal line right there. And x equals -6, it's right there. And as you can see, those two form a right angle. So we know that they are perpendicular. So a horizontal and a vertical line are always going to be perpendicular. So even though you look at this equation and you say, well, wait a minute, what's the slope of a horizontal? 0. What's the slope of a vertical? Undefined. So I can't really say they don't have opposite reciprocal slopes, but they kind of do. So what about y equal 2x plus 3 and y equal -1/2 x plus 6? Let's take a look at those. If I graph those, 2x plus 3, let's see, the y-intercept is 3. It has a slope of 2, up 2 over 1, up 2 over 1, up 2 over 1. So something like that. And the next one, the orange one, has a y-intercept of positive 6. That's right there. And a slope of negative 1/2. Down 1 over 2, down 1 over 2, down 1 over 2, etc. Kind of missed it there. Well, that's 6. 1, 2, 3, 4, 5, 6, yeah. And then that would bring this down here. And it turns out that those two lines intersect at a 90-degree angle, so they are perpendicular. So if we don't have horizontal and vertical lines, how do we tell if they're perpendicular? Well, two lines have opposite reciprocal slopes, then they're perpendicular. And we need to talk about it. What does that mean? Opposite. That means one of them's positive, the other one's negative. Reciprocal. Reciprocal is like 2 over 5 and 5 over 2. So if one of them's a negative 2/5 and the other one's a positive 5/2, then those are going to be, that, and I'm referring to the slopes of lines, then we know those two lines will be perpendicular. Let's look at a few examples. For each of these pairs, are the lines parallel, perpendicular, or neither? Because remember, if they're not parallel, that means they intersect. But they don't necessarily intersect at right angles all the time. So if they do intersect at right angles, they're perpendicular. But if they just intersect, but they're not perpendicular, then that would be the neither of your choices. Okay, so let's look at the first one. Notice what form this is in. This is in slope-intercept form, and the slopes are both -3. Well, if the slopes are the same, we know that they're parallel. And sure enough, if you graphed them, you'd see they're parallel. For the next one, the slope of this line is 2, and the slope of this is -1/2. Now you can think of 2 as a fraction 2 over 1. And that's easier to notice then that they are opposites, positive, negative, and we flip them, they're reciprocals, 2 over 1, 1 over 2. So if we graph those, we would see that they form a right angle. So they're perpendicular. On the last one, we have a slope on this line is 3/2 and the slope here is 2/3. Those are reciprocals, but they're not opposite reciprocals. They're both positive. So therefore, they're not parallel, they intersect, but they don't intersect at right angles. And indeed, that's what it would look like if you graph those. So putting down our answers here, parallel, and the parallel symbol, if you remember from geometry, is there. Perpendicular, and then neither. All right, let's try a few more examples, writing some equations. Find the equation of the line that's parallel to y equal 1/2 x plus 2, and it contains the point -2, 6. Okay, so first of all, equation of the line. They don't specify what our equation looks like. So we could do slope-intercept. We could do point-slope. So let's keep that in mind for a minute. Now we want the line that's parallel to this line. What do we know about parallel lines? They have the same slope. So that means that the slope of my line has to be the same, which is 1/2. Now, did they give me a y-intercept? No. Did they give me a point? Yes. So I think I want to use point-slope form. That would be the easiest for me. I don't have to, but why do more work than I need to? So for point-slope form, remember what that looked like. Y minus y sub 1 equals m times x minus x sub 1. And I know the m, and I have a point, so I can just go ahead and write it. Y minus the y coordinate, which is a -6, that becomes y plus 6, equals my slope, which is 1/2, times x minus the x coordinate is a -2, so that becomes x plus 2. And if you want, you can graph it and compare, and you'll see that it is parallel to that line. If you want to put it in a different form, feel free. There's no right or wrong here because it doesn't specify what form of equation you need to write. but that's the easiest one. Find the equation of the line perpendicular to y equal negative 2/3 x, which has a y-intercept of 7. Okay, so let's think through this process. Equation of the line, they don't specify which form, we'll determine that later. Perpendicular to this line. What do we know about perpendicular? They have opposite reciprocal slopes. If the slope of this line is negative 2/3, the slope of my line, which is perpendicular, will be a positive 3/2. So I have the slope. Now what else did they tell me? It has a y-intercept of 7. Well, that would mean that it would be easiest, instead of doing point slope form, how about we do slope intercept form? And that is y equals mx plus b. Because I figured out the slope and they gave me the y-intercept, the b. So I can write my answer as y equals, you don't have to write the positive, 3/2 x plus 7. I guess if you wanted, if the y-intercept is 7, that tells you it goes through the point 0.7. So we could have used point slope form, but when you set it up, it would become y minus 7 equals 3/2 x minus 0. And you can see that if we just move that 7 to the other side, we'd have that point slope equation. So once again, decide which equation is easiest for you and go with that. All right, let's try another one. Find the equation of the line containing the point 4,9. It's perpendicular to the vertical line that contains the point negative 5,6. Okay, so there's a lot to unravel here. So you have to think through these problems because there's so many different variations that you can get. All right, so we need the equation of the line. So our answer is going to be a line. Maybe y equal mx plus b. Maybe we like this form, y minus y1 equals m times x minus x1. Okay, this is if, we're just trying to not think too much, but we're following the pattern of the last two examples. It contains the point 4,9, so I know that point is on my line. It's perpendicular to the vertical line that contains the point negative 5,6. Okay, so what do we know about perpendicular? They have opposite reciprocal slopes. But I didn't give you the equation of the other line. I just told you it was vertical and it contains the point negative 5,6. So sometimes it helps to visualize these things and say, wait a minute, a vertical line, negative 5,6 is right about here. And a vertical line, stay color coordinated here, that goes through that point would be this. What's the equation of that line? Oh, that's x equals negative 5. Now I want, that's a terrible 5. I want a line that's perpendicular to this that goes through the point 4,9. So where's 4,9? That's going to be maybe right up about here. Let's say that's 9 and that's 4. All right, and so if it's perpendicular, a vertical line, then perpendicular to a vertical is going to be a horizontal line. It's going to be that one. And what's the equation of a horizontal line? Well, that would be y equal 9 in this case. So I didn't need to approach this the same way I did the last two problems. My answer is just y equal 9. Let's read through the problem again just to make sure we did it correctly. Find the equation of the line. I have the equation of a line. It happens to be horizontal. Contains the point 4,9. Yep. It's perpendicular to a vertical line. Yep. So we're good. So what I don't want you to do is always just dive into a problem. I want you to think about it. Even if you take 5 seconds. Ready, go. 1, 1,000. 2, 1,000. 3, 1,000. 4, 1,000. 5, 1,000. Doesn't seem like a lot of time. If you take 5 seconds before you dive in and start doing some work, you might save yourself a lot of work and a lot of frustration as well. So when you're working through these problems, think of all the different approaches you can do. Sometimes picturing it with a graph is worthwhile. Sometimes just diving in analytically, depending on what they give you, is the way to go.